students, today's agenda is to check homework. We'll be learning about exponential functions and you will be able to do page 12. Today's objective is to rewrite exponential functions and to identify whether it represents an exponential growth or exponential decay. And this is the form of the function y equals a multiplied times 1 plus the rate to a power. And that will represent exponential growth when you're adding. So the base or common ratio will be greater than 1. The other one is y equals a times 1 minus r. And in here, because you're subtracting, then this is going to be less than 1, between 0 and 1. And so that's exponential decay. This is the common ratio or base. But if you notice in here, we'll read the instructions in a minute, but in here you will notice that formula you only have to the power of t, whereas in here you don't have a to begin with, that will be a 1, and then you have either addition, subtraction, multiplication, and multiplication with a fraction for some of them. So it says rewrite the function to determine whether it represents exponential growth or exponential decay. Then identify the percent rate of change. So we're going to be doing 3 things. We're going to rewrite the functions. We're going to decide whether it's growth or decay. And then we're going to decide by what percent it's growing or decreasing. Okay. Number 1, we have y equals 0.7 to the t plus 2 power. Whenever we have addition or subtraction in here, what we're going to do is to separate, and I'm going to use this first because that's going to become our initial point. It's 0.7, which is that base, to the power of 2 times, and then this will become the base or common ratio. We keep it the same, 0.07 to the t power. Okay, again, what I did is have this twice. It's multiplication with the plus is here and with the t is over here. Now we're going to raise this to the second power. So we use our calculator and it's going to be 0.7. So 0.7. The power button, remember that it's different for different calculators. So this is the power button. Sometimes you will have x to the y power, or sometimes x to the, and then there is a little square like that. Okay, so in this calculator is this one right here. I press that and that's what shows, and so I put to the second power equals, and so that's going to be my initial point, 0.49, and then I just bring down times 0.7 to the t power. Now, when it's asking for the percent rate of change, it's not going to change from whatever they give us. Okay, so whenever it's less than 1, that's actually a decrease, and we can say that it's going to be an exponential decay. Not only that, for decay, you cannot just see it right there. Okay, you cannot get it from our function. What you need to do is subtract 1 minus whatever you have in there, which is 0.7, and that's 0.3. You move the decimal space 2 times, and so it's going to be of a 30% decrease. Or you can use your calculator. 1 minus 0.7, it's 0.3. Move it twice, is 30%. Okay, 30% decrease. So that's for number 1. For number 2, we're going to do the same thing. However, we have to be careful because this is a negative exponent. So this is going to be equals to, we keep the same base, 1.02 to the t power. Okay, over, why do I put it over? Remember that with negative exponents is this base to the -4 power. Remember that negative exponents you send to the dungeon, al calabozo. So it's going to be 1.02 to the, now it's +4. So I'm going to separate this, sending it over here. as 1.02 to the t power. But then in here, I'm going to put 1 over 1.02 to the 4th power, which came from there, okay? So I'm just separating it. Here, I put it as a whole, right? I don't have a fraction. You can go directly from here to here if you want to. That's only when I have a negative exponent. 1 over, and then the base to that power, now positive. And then again, that to the t power. So this is going to be, again, if you want to skip this step, all you have to do is write that to the t power to the right side. And then to the left side, you will put 1 over that same base to the 4th power, but now positive because it already went to the denominator. In the calculator, you're going to put 1 divided by, open your parentheses, 1.02, close your parentheses, and then the power button, 4. 0.92. So that's my initial point, 0.92. The 3 does not give anything to the 2 because if it's 5 or more, it gives 1 more. But if it's 4 or less, then it stays the same. Times, we copy the same base, 1.02 to the t power. So the base is more than 1, so that's an exponential growth. And how much, ignoring the 1, in here we can see in decimal form how much it grows. So we move the decimal space 1, 2, it will end up in here, so that will be 2%. So it has a 2% increase. Okay? So that was for addition and subtraction. For addition, you just put it as multiplication next to each other. The t goes down here, and the 2 goes over here. For the negative, you put with the t goes over here, with the negative 4 goes over here, but as a fraction to send it to the denominator to make it positive. Then you divide 1 by 1.02 raised to the 4th power to make the initial point, and just copy this. In growth, it shows me the percent rate of change. In decay, I have to subtract that from 1 to get the percent rate of change. For number 3 and 4, it's a little bit different. It's basically just raise the power to another power. This one, you keep it already has an initial point, so you just keep it. And in here, you're going to have brackets because you have the original base, which is 0.6, raised to the 5th power. We're just separating that part right there, okay, to the 5th power. And then the t just goes out here. Now, in our calculator, what we're going to be working with is this part right here to create a new base. So you notice that in addition and subtraction, the common ratio or base did not change. In here, it will. So we keep the initial point. In the calculator, you're going to put 0.6, power button raised to the 5th power, equal. And that's going to be your new base or common ratio. So it's going to be 0.08. The 7 gives 1 more, okay? 5 or more gives 1 to the previous one. So to the t. So this became this right here. Remember that we're rewriting what they give us. So we end up with t as the exponent, and we have an initial point. Okay, now let's identify. Now that we have t only, because this base is less than 1, what I'm going to do is 1 minus that amount, 0.08 equals, that's my rate of change. That's my percent rate of change. Okay, always when it's less than 1, you put 1 minus whatever you have in here, and whatever you get, that's the rate of change. Okay, so it's going to be 0.92. You move it 2 spaces, which is equals to 92% decrease. And again, before writing this, we knew that it was, because it's less than 1, it's a exponential decay. So in here we separated this, right? 5 times t, the 5 went inside, the t is out here. Remember that when we multiply, when we have power raised to another power, is multiplying them. For number 4, it's a little bit different. How do you separate this? T over 5 is the same as 1/5 multiplied by t. Okay, so we're going to separate this. The initial point stays there. We put brackets, put the base, and again, this is the same. T divided by 5 is the same as 1/5 times t. Okay, why? Because remember we put it over 1. T times 1 is t, and 5 times 1 is 5, so t over 5. So in here we're going to separate it by putting 1/5 right here, close the brackets, and then t outside. Okay, by multiplying them, that becomes 1/5 of t, which is the same as t over 5. Now this is what we're going to put in the calculator. So the initial point stays the same. Where are we going to get for the new base? Is 0.72. We're going to put the power button, okay, the base, then the power button, and then in here I'm going to ask you to open a parenthesis just because we have a fraction. So to the power of, open parenthesis, we're just going to put 1 divided by 5, close our parenthesis, and we press equal. Again, when we have a fraction, you have to open parentheses and close parentheses and put this as division. The new base is 0.90. It says 93, but because the next number is a 6, remember 5 or more, then it gives 1 more in here, and then to the t power. This is my initial point. This is my base or common ratio. Because this is less than 1, again, is exponential decay. Whenever we have decay, we subtract 1 minus that amount, 0.94, and that's in decimal form. That's the percent rate of change. We move it 2 spaces, so it's a 6% decrease. Okay, in decay, we subtract 1 minus that, and that's whatever we get. We move the decimal point 2 spaces. I hope this lesson helped. If you would like to support our channel, please give us a thumbs up, subscribe around here. This is the link to the next lesson, and here you will find the entire unit. Now you're able to do page 12 and have fun.